Magis Day students, welcome to another day of learning. In this video, you will recognize other special polynomial product pattern and use these patterns in multiplying binomials. So for this video, we will focus on square of a binomial and cube of a binomial. In my previous video, I talked about the pattern of the first type of special product, which is the sum and difference of two terms. Now, the second type of special product is formed by squaring a binomial. Take for example the quantity of x plus 4 squared and the quantity of x minus 6 squared. These are two examples of binomials that have been squared. Let's look at the first example, the quantity of x plus 4 squared. Take note that that the quantity of x plus 4 squared is actually equal to the quantity of x plus 4 times the quantity of x plus 4. This is in courtesy of product rule of exponent. Remember, so we just have to multiply the base, the quantity of x plus 4, to itself twice since it is being squared. And if we're going to do FOIL method, we will get x squared plus 4x plus 4x plus 16. Right? First term times first term, outer term times outer term, inner term times inner term, and last term times the other last term. Right. Now, if we're going to look at our product, notice that we have here 4x and 4x as our like terms, which means that we can still combine them. Right? So the 4x plus 4x will now become 8x. So our final product for the quantity of x plus 4 squared is equal to x squared plus 8x plus 16. Now, whenever we square a binomial like this, the same pattern always occurs. So what's the pattern? Remember that for every square of a binomial, the product is always a trinomial, which then will lead us to the conclusion that the first term of the product is always the square of the first term in the binomial. The second term of the product is actually twice the product of the two terms. And the last term of the product is always the square of the last term in the binomial. So as you can see, we only have three terms for our product in squaring a binomial. So we have the first term, which is the square of the first term in the given, and the second term, which is twice the product of the two terms, and the last term, which is actually the square of the last term. Now let's apply the pattern, and let's have here first example, the quantity of x plus 3 squared. If we're going to expand this one, we will then have two quantities of x plus 3. And actually, we will not be using this because this is only done if we're going to do FOIL method. But I want you to remember the pattern always. If it's square of a binomial, the pattern says the first term of the product is the square of the first term of the given. Going back to the given, our first term here is x and our last term is 3. Okay? So a squared, square of the first term is x squared, and then twice the product of the first term and the last term. So we have 2 times 3, which is the last term, times x, which is the first term. And then we have here the square of the last term. Our last term again is 3, so we square it, 3 squared. But this is not the final answer yet because we still have to simplify. So we have x squared. There's nothing we can do about this. So we have to copy. 2 times 3 is 6 times x, 6x, plus 3 squared is 9. So this one here is our final answer. X squared plus 6x plus 9. So this is our first example. Now let's have our second example, the quantity of z minus 4 squared. Still the same process, right? So our first term here is z, and our second term, our last term is negative 4. Okay, so again, we squared the first term. So we have here z to the power of 2 plus, okay, let's put plus here first. Anyway, the last term is negative, so it will still look like this for our final answer. Plus twice the first term times the second term, I mean the last term, so negative 4 times z. And then we square the last term. So we have here negative 4 squared. Right. But again, we still have to simplify this to make it look better. So we have here z squared. Multiply the two coefficients, 2 times negative 4. That's actually negative 8. Negative 8 times z, so it's a negative 8z. We won't write plus anymore because the sign is already negative. And then we square the negative 4. That is negative 4 times negative 4, positive 16. So we put here plus 16. So this is our final answer. All right. Next example. Now let's have our third example. This time I'll choose I'll come up with something more challenging. So we have here the quantity of x plus 3 times the quantity of 2x minus 5 times the quantity of x plus 3. So as you can see, we have here three binomials already. But take note, um, we have here two x plus 3's, which then will lead us to a conclusion that we can write this as the quantity of x plus 3 squared is equal, the quantity of x plus 3 squared times the other binomial, which is 2x minus 5. And from here, take note that we can apply the pattern. Okay, so in this case, our first term is x and our last term is 3. Okay, so allow me to write it somewhere here. All right. So again, the first term of the product is the square of the first term. So the first term is x, so we square it, x squared. Followed by twice the product of the last term and the first term. So 3 times x. And then plus the square of the last term. So 3 squared. Then we put it inside an open and close parenthesis because we still have here another binomial which will which we have to multiply our product here with it, 2x minus 5. We simplify this, so we have x squared plus 6x plus 9. But that's not a final answer yet because we still have 2x, the quantity of 2x minus 5. And here, remember, it's either you apply box method, since it's all about multiplication of polynomials already. It's either you apply box method or the distributive property of multiplication, which means that we have to uh, distribute the 2x and the negative 5 to each of the terms inside this trinomial, So let's begin. 2x times x squared, that's 2x cubed. Okay, and then 2x times 6x, that is 12x squared. 2x times 9 is 18x. And then negative 5 times x squared is negative 5x squared. Negative 5 times 6x is negative 30x. And then negative 5 times 9 is negative 45. Okay? But again, we won't stop here because this is not simplified yet. So we have to combine like terms if there's any. So as you can see, we don't have here any other terms which has an exponent of to the power of 3. So we have here 2x to the power of 3. But we have here 12x squared and negative 5x squared. These are like terms. So we combine them, we get plus 7x squared. Then 18x and negative 30x. So that's actually negative 12x minus 45. So there you go. We have 2x cubed plus 7x squared minus 12x minus 45. And this is our final answer. Allow me to put it. All right, there you go. Now, let's have cube of a binomial. The cube of a binomial, say for example, the quantity of x plus y is the sum of four terms where each term can be obtained as follows. The first term of the product is actually the cube of the first term of the given. The second term of the product is thrice the product of the square of the first term and the last term. While the third term of the product is thrice the product of the first term and the square of the last term. And for the fourth term of the product, it's actually the cube of the last term. Okay, so take note that for this example, for this pattern, we will always have four terms in our product. All right, so let's have your first example. The quantity of 2x plus 1 to the power of 3. So if we're going to expand this one, we will have three quantities of 2x plus 1. But we will not do that anymore because we will not be applying FOIL method here. Let's go straight to the pattern for cube of a binomial. But first, we need to identify that our first term here is 2x and our last term here is 1. This is our last term. So the first term of the product is the cube of the first term. So that means to say we have we have here the quantity of 2x to the power of 3 because it's the cube of the first term. Plus, so 3 times the first term, the square of the first term, 2x squared times the last term. Plus, thrice the first term and the first term is 2x. Okay, allow me to erase. The first term is 2x, and this time it's not the first term that we will square, but it's the last term that we will raise to the power of 2, followed by the cube of the last term, 1 to the power of 3. So as you can see, it's thrice the product of the first term and the square of the first term and the last term. When this time, we have here thrice the product of the first term and the square of the last term. So we square the first term first, and then we also have here the square of the last term. Then we simplify because this is not simplified yet. So we have 2x times 2x times 2x, it's 8x to the power of 3. Plus 3 times 2x squared. 3 times 2x squared is 4x squared. For any number multiplied to 1 is just the number itself, so there's no need for it for us to put 1 again. Plus 3 times 2x is 6x. But we have here 1 squared, and 1 squared is equal to 1. It's just equal to 1. So 1 times 6x is 6x. Okay, for a while. 6x. And then we have here 1 times 1 times 1 is 3. I mean 3, sorry. 1. Okay. And then we simplify again. 8x to the power of 3 plus 12x squared plus 6x plus 1. So this one is our final answer. 8x to the power of 3 plus 12x squared plus 6x plus 1. Now let's have here our second example. So it's the quantity of x minus 2 to the power of 3. And again, if we're going to expand this, we will have 3 quantities of x minus 2. But we don't have to do that one because that's only for checking and also to save time. So we will go straight to the pattern. So here our first term is x and our last term is negative 2. And the pattern says the first term of the product is the cube of the first term in the given. So you have here x to the power of 3, followed by thrice the product of the square of x. So we have here x squared times the last term, which is negative 2, plus thrice again the product of the first term x, and this time it's now the last term that we have to square. Okay, a while ago it's the first term that we raised to the power of 2, and now we square, this time we square the last term. After this, the last term of the product is actually the cube of the last term in the given. So our last term there is negative 2, so raised to the power of 3. So we now have to simplify. X to the power of 3, there's nothing we can do about this because it's already simplified, plus multiply the two coefficients. 3 times 2, that's negative 6. So you have here negative 6x squared plus 3 times x, 3x. But take note, we still have here 2 squared. What is negative 2 squared? That's positive 4. No? Negative 2 times negative 2, positive 4, plus negative 8. Alright. Then we simplify because we're not yet done. We have here x to the power of 3. Positive times negative is negative 6x squared. Then we have plus 3x times 4 is 12x. And then we have negative 8. So if you're going to check on it, no, if you're going to review, we have x to the power of 3 minus 6x squared plus 12x minus 8. Because positive here, positive times negative is always negative. So that's why instead of putting plus, we put minus 8. So this is our final answer. We have x to the power of 3 minus 6x squared plus 12x minus 8 as the product of the quantity of x minus 2 to the power of 3, the cube of x minus 2. So I hope that's it. I hope you have learned how to uh, solve for the product of square and cube of a binomial without using FOIL method, but through its pattern. And I hope you will be able to apply it in solving problems relating to these type of special products. Thank you and see you in my next video. Bye everyone.